By the end of this lesson, you'll be able to use Ruby enumeration methods like each, map, select, and reduce. Functional programming is a programming paradigm that treats computation as the evaluation of functions. It avoids changing state and mutable data, and it's also declarative. In functional code, a function's return value depends only on its arguments. So calling a function with the same value always produces the same result. In contrast, in imperative programming, a sequence of statements determine how to reach a certain goal. These statements change the state of the program as each one is executed in turn. The most commonly used methods in functional programming are map, select, and reduce. For each of these methods, we will perform a task using each and some imperative commands. Then we'll complete the same task using functional programming. First, we need to talk about each. Each is a method available on arrays that calls the given block once for each element in the array, passing in that element as a parameter. Let's look at an example. So here we have an array that is assigned to the variable a. The array contains 3 string values, a, b, and c. Now, this is a very simple each method, but we'll call each on the a variable. And we have a block variable called x, and we're going to simply print that variable out to the console. Now, exactly what happens is what we would expect. We have a, b, and c printed to the console. Notice that the return value is the array that each was called on. Now, the map method applies a specific function to each element of an array. The imperative way to accomplish this task would simply be to loop through the array and apply the necessary changes to each element from within the loop. The map method simplifies this process. As an example, let's say we had an array of strings, all with different cases. So in this example, we're going to use the Beatles. So we have an array, John Lennon, Paul McCartney, Ringo Starr, and George Harrison. And we want to create a corresponding array of lowercase strings and replace any spaces with hyphens. For example, maybe we're using these strings for URLs. The first way we'll accomplish this is with the imperative method. We'll define a method called imperative URLs, where we accept strings as arguments. Here we're defining inside the method an empty array called URLs, and then on strings we will go ahead and call each, passing in the block. Now for each string, we're going to push in the downcased version of the string, and then any white space character, we're going to split it and then join it with a hyphen. Now you can see when we call imperative URLs, it returns an array that does exactly what we set out to do. Now let's look at how we can use a functional map method that makes this much simpler. Now in this case, we call map directly on the Beatles array we created originally, and each time it iterates through Beatles, we'll have Beatle available as a block variable, and we can just directly downcase that, split it, and join it with a hyphen. We accomplished the exact same thing with one line instead of many lines. It also eliminates having to use a URLs array temporarily that's stored in memory, and we don't really need that. Let's look at selecting now. The select method allows us to select elements from our data based on a Boolean criterion. So we can test each item in an array for a specific thing we're looking for. Like suppose we had an array of integers and we wanted to keep only the even integers. To do that the imperative way, we'll define a method called imperative evens that accepts an array of integers. Now in this case, just like the previous one, we have to create an empty array that we're assigning to evens, then we're looping through integers that we passed in using each, and then we're testing. If the integer is evenly divisible by 2, then we'll go ahead and add that integer to the evens array we created, and at the end we'll return the evens. To do that functionally, we call select directly on my integers, and then we can pass in that test directly to our block. So in this case, we'll say each integer in my integers, if it's evenly divisible by 2. So if that test returns as true, then we want to keep that one. We want to select that integer. And you can see it returns an array with only 2, 4, 6, 8, and 10. Again, you'll notice the functional version is much more concise and again avoids mutation and the intermediate array. Now we're going to talk about reduce. The reduce method allows you to accumulate a single value from a given array. For example, you could reduce an array into a single value representing the total length of every string element in the array. For the Beatles example we've been using, this would result in 51. You can also get more creative. You could take an array and reduce it into a hash, where each key is the lowercase name of a Beatle, and each value is the length of the key. We want to create something that will look like this. To do that the imperative way, we'll define a method called imperative length that expects an array. We have to define a length variable that is equal to 0. And then we'll loop through the array, and for each element in the array, we're going to add to the length, whatever the length of that element is. And at the end, we'll return length. For the next example, we're going to create the hash that we had mentioned. We'll define a method called imperative lengths hash that expects an array. And in this case, we'll start out with an empty hash called lengths. We'll loop through each item in the array, and we're going to make the key of lengths. We're going to add a new key value to that lengths hash, where the key is the downcased element, and the value is the length of the element. And at the end, we'll return that new hash that we created. Now you can do this exact same thing the functional way by using reduce. So here we're calling reduce directly on Beatles, and we're passing in the starting state of the object that we want to return, or the value that we want to return. So in this case, we're passing in that empty hash. Then we're passing in a block where we say we are going to need access to length and Beatle. Now lengths, in this case, is that starting state value that we pass in, that starting state object, in this case a hash. And then the second item, Beatle, is each item in the array that we're looping over. Now you can see the logic inside the block is actually similar. We're going to take that length hash and we're going to add key value pairs. In this case, the key is the downcased Beatle, the string from our Beatles array, and the value is the length of that string. And in the end, we'll return the length value. You can see we've achieved the same result. Again, notice that the parameter value, or the argument value for reduce, should be whatever we want our starting value to be. The block then represents how we want to modify the starting value with each iteration. In this case, we started with an empty hash, and with each iteration through, the array added a new entry to the hash. The benefits of using reduce over the imperative solution in this case isn't as clear. The logic looked very similar. A case could be made that the imperative solution is actually a bit easier to understand. However, reduce is a common technique among more advanced programmers and is absolutely necessary when you start dealing with large data sets and need to do it efficiently. Let's go ahead and do this next section together. So we're going to create an array of Tesla models. So simply, we're just defining an array and we're going to call it Tesla models. We're passing in Roadster, Model S, Model 3, Model X, and Model Y. Now we're going to start by using this the imperative way, and we're going to use each to print the length of each model to the console. Now let's map over each of the models and make the strings URL friendly. Okay, next we'll go ahead and select only the models that have the string model in the name. Last, we'll create a hash that shows the length of each of the model names using reduce. Now, complete the following steps on your own. First, create an array of strings with each string using a different casing. Then use each to print each string in the array to the console. Then use each of the functional methods we've talked about, map, select, and reduce, on your array to do the following. 1. Use map to make all the strings URL friendly. Use a Boolean criterion to select only certain strings from your array. Lastly, use reduce to construct a hash that uses each string as a key and associates some related piece of data, could be the length of the string, you get to decide, with each key.